everyone. Welcome to This Is CDR from OpenAir. Very pleased to have you here with us today. This Is CDR is an online event series we've been hosting since, I guess, early August to explore the wide range of carbon dioxide removal solutions currently being researched, developed, and deployed, and to contextualize them for a policy proposal we're working on for New York and other states and jurisdictions called the Carbon Dioxide Removal Leadership Act. Some quick background on OpenAir. We're a distributed volunteer network dedicated to the advancement of carbon dioxide removal solutions essential to solving the climate crisis. We are a growing global community, and we work together on shared open source missions in the areas of research and development, policy advocacy, and market development. There should be a link in the chat where you can check out our website, and there's a form on the website so you can join our Discord server, which is kind of where we communicate. Also, if you haven't already, I see that many of you have, please introduce yourself in the chat and tell us where you're zooming in from. Quick background on carbon dioxide removal, which I know many of you are already quite expert on, but for those who maybe aren't, carbon dioxide removal is very specifically activities that remove CO2 from the atmosphere and durably store it in geological, terrestrial, or ocean reservoirs, or in, as we'll discuss today, long-lived products. Whenever we talk about carbon dioxide removal, it's really important, first of all, to emphasize that it is in no way an alternative to reducing emissions. We need to reduce emissions as completely and as quickly as possible, full stop, to decarbonize our economy. That said, there are going to be some emissions that are hard to abate, and we have already emitted, many gigatons of CO2 in the atmosphere. So basically, every climate survey and forecast say that gigaton scale carbon dioxide removal is going to be essential by mid-century to deal with these hard to abate emissions and to restore our climate to a safer and healthier place. And that's why we're here today, to learn more about CDR. If you would like to research it a little bit further, there should be a link in the chat to the CDR primer, which is a great resource to kind of give you a broad background on the topic. These episodes, we've done about almost 10 of them now. They're available on our YouTube channel. Great survey of what's out there in terms of CDR solutions. And we'll put a few other links to resources that we like in the chat so that you can check those out. Let me hand it over to my colleague, Megha, to introduce today's speaker.
Hi, everyone. I'm Megha Raghavan, based in London. I also work on OpenAir's CDR policy advocacy team with a particular interest in the legislative opportunity for California, which is where I'm from. This week, we're very excited to welcome Aaron Fitzgerald to tell us more about Mars Materials' efforts to develop a new pathway for carbon fiber production using captured CO2 as a raw material, and to discuss his experiences with New York's carbon tech ecosystem as a part of Venture for Climate Tech and the C2V initiative's inaugural cohorts. The usual housekeeping notes. So our format is going to be a 15 to 20 minute presentation, followed by a few prepared questions, and then we'll have moderated audience Q&A. So please do type any question you have for Aaron into Zoom's Q&A box. Note that that's separate from the chat box, so make sure you find the one labeled Q&A. We will also be live tweeting today's event, so we'll post our Twitter link in the chat. I believe it's already in there in the chat box. So please do follow along, and if you tweet, the event hashtag is ThisIsCDR. So now for the main event. Aaron Fitzgerald is the CEO and co-founder of Mars Materials, a certified B-corp that sequesters captured CO2 into plastics and carbon fibers by converting it into acrylonitrile, and that can be used to create a wide range of long-lived products. Mars Materials was incubated while Aaron was an entrepreneur in residence at Carbon 180. Aaron, over to you.
Thank you so much. And I'm just going to take time to share my screen really quickly. Well, thank you so much, Toby and Megha, for the introduction, and the OpenAir community again for having us. So as you guys know, I'm Aaron Fitzgerald. I am the CEO and co-founder of Mars Materials. At Mars, we are working to store captured CO2 into products that are part of our everyday lives. Today, we are a team of 4, including 3 chemical engineers, and guiding us along the way is our lab partners at NREL, which is the nation's only applied national lab, and other mentors and advisors representing firms like Carbon 180, NYSERDA, Google Ventures, and others. And today we're commercializing Nitrolation, which is NREL developed carbon tech that enables us to produce the raw material for carbon fiber and other materials. And our technology enables us to produce this material cheaper. We can do it with fewer emissions and using captured CO2. At full scale, each unit has the potential to sequester about 42 kilotons of CO2 per year. And before I dive more into our technology, I thought I'd quickly walk you through Mars Materials and how we got here. So as Megha said, we are certified B-corp. We were founded in 2019. And this really started after I left a company called Kairos Aerospace, which is an aerial imaging, methane imaging startup. There, I witnessed just how leaky our infrastructure, like oil and gas fields and landfills are. As you can see pictured here is a super emitting methane leak. I was compelled to do more to help the planet, and I set out on a discovery. I wanted to learn why industrial decarbonization was happening so slowly, and specifically at the time, I was really focused on landfills. My discovery led to a collaboration with Lawrence Livermore National Lab. And around that time, I joined Carbon 180 as an entrepreneur in residence. During my fellowship at Carbon 180, I was charged with identifying business models and technologies that would enable me to build a business capable of removing 1 billion tons of CO2 or equivalent from the air. I was given this incredible opportunity to learn from climate scientists, industry experts, policymakers, and connect with other national labs like NREL. And these experts really helped me to create the foundation that I needed to hopefully long-term be successful in carbon dioxide removal, and help me find a pathway that aligns with my particular interests. So at Mars, we're focused on carbon tech. And for me personally, carbon tech is interesting because of its ability to sit at this nexus of decarbonization, which is very critical and necessary, as Toby mentioned, and carbon removal, which has also become this new necessary technologies that we need. And for us at Mars, that means that we work to create a commercialization sweet spot where we're able to take a large supply chain or one with exceptional growth potential and transition it to using captured CO2 as a feedstock. Following the principles of carbon removal, we prefer to target long-term products and, long-lived products. And from our perspective, this is important because the many scenarios, including the one depicted in the chart on the screen, highlight carbon tech's really exceptional use potential of captured CO2 by 2050. And in the case of this chart, what you see here is the central scenario assumes 60% of captured CO2 will go towards carbon tech, while that remaining 40% will be sequestered. And the more I learned, the more I wanted to find a killer technology that would enable us to use an outsized portion of this estimated captured CO2. So I set out on a technology discovery. And about a month into my search, I met my eventual co-founder and chemical engineer, Christian Gutsch. Together, we created a rigorous market-focused framework and reviewed carbon tech solutions that from the various national labs, including NREL. In the end, we chose NREL's Nitrolation. And we chose Nitrolation because of its potential to reduce costs. Carbon fiber is a market with exceptional growth potential. And its ability, and then we also selected Nitrolation because of its ability to use captured CO2 as a key raw material. And we'll get more into our technology in a minute, but I really want to talk about carbon fiber because it's so integral into why we selected Nitrolation. So carbon fiber is a $6 billion market today. It's a material that's lighter and stronger than steel and aluminum, and it can be used as a drop-in replacement for these materials and other hard to decarbonize materials. Steel production and aluminum production combined make up about 11% of total global emissions. And during my Carbon 180 fellowship, I really became transfixed with the idea of decarbonizing these industries, really figuring out what could be done. And the more we conducted diligence on the carbon fiber industry as a potential replacement for these industries, we took time to speak with industry experts across the entire carbon fiber value chain. We met with raw material buyers, manufacturers, all the way down to downstream to end-of-life experts. And they all really convinced us that this material's potential is huge, and its potential to be a powerful decarbonization tool is really untapped. But the issues plaguing this industry is really how can we get to a future where carbon fiber is used more widespread? And the challenges associated with that today are carbon fiber production is expensive, it's energy and emissions intensive, and the material is not produced sustainably. So there are industry goals really with each individual manufacturer to get carbon fiber to carbon neutral. because today 1 ton of carbon fiber generates up to 31 tons of CO2. And that's just unacceptable. So you can track these emissions across the entire carbon fiber processing chain. And we, for the purposes of today's conversation, kind of group them into 4 categories, starting with the precursor. And carbon fiber has kind of one sole precursor, so one sole raw material. And this step of the material life cycle really involves the raw material for carbon fiber and the steps to produce it and spin it into a fiber. This process step is also responsible for about 51% of the total cost. As you move down the processing chain, we move to a step called carbonization, converting the precursor into the fiber. The material during this step undergoes a thermal conversion from precursor to carbon fiber, and this is the most energy-intensive step of the process. Moving further down the chain, we get to molding. And this is where the fibers are impregnated with a resin, they're molded, and then they're cured, creating the materials that we kind of see from carbon fiber today. And then finally, there's an end of life for these fibers. And for the remaining portion of this presentation, we'll discuss primarily the precursor challenges, as that's where we at Mars fit into this market. So today, there are 3 main precursors used for the production of carbon fiber. The dominant precursor, which represents about 90% of all produced carbon fiber, is polyacrylonitrile, or commonly called the PAN precursor. Other 2 precursors are rayon and pitch, and they're used in much smaller volumes. Half of the cost of carbon fiber really results from creating the PAN precursor. And that's split into 2 phases. You have the cost of PAN sole raw material, something called acrylonitrile, a chemical called acrylonitrile. And you have the cost to polymerize acrylonitrile and spin it into polyacrylonitrile PAN. So there are a lot of exciting techniques being developed to improve the polymerization of acrylonitrile to PAN. And I would encourage you to connect with me if you'd like to learn more here. But the production of acrylonitrile is an entirely different story. And I'm really excited to share how we plan to transition the acrylonitrile market to better technology. So acrylonitrile is a $12 billion commodity monomer. And I can talk your ears off about acrylonitrile and its many uses, but for the purposes of today's conversation, what's more important is that acrylonitrile is wholly petrochemical derived. The conventional method to produce acrylonitrile is through propylene oxidation. So propylene oxidation works by taking propylene, ammonia, oxygen from the air, all of these as feedstocks, and running these inputs over a catalyst to produce acrylonitrile. There are byproducts associated with this process, namely acetonitrile and hydrogen cyanide, which are also used to subsidize the cost of producing acrylonitrile. And in the aggregate, this process has been commercialized and industrialized as the Sohio process. And this Sohio process is responsible for about 90% of all acrylonitrile production. Depending on the year, it can fluctuate between 90 to 95%. And Sohio plants are massive. Propylene oxidation is an exothermic reaction, and it requires large reactors to avoid runaway reactions. The plants are known to suffer from frequent downtimes and other issues that all lead to the instability of costs to produce acrylonitrile today. In addition to this, the reaction has pretty low yields, and it uses a mix of grid and natural gas for energy. So from our perspective, it's just really time to retire this process. One of the biggest questions I think everyone always has is, it's inevitable that we need to transition off of petrochemicals, but the question really becomes when and how. And the more we investigated the Sohio process and Sohio plants, the more we recognize that the time is today. As you can see here, the market is really demanding a cheaper alternative to acrylonitrile. And the manufacturers that we spoke with are also recognizing that in addition to a cheaper alternative, there needs to be a more sustainable alternative. And that's where nitrilation comes in. So, pardon, we're gonna get a little bit more into the chemical weeds on this, but nitrilation is an alternative chemistry platform. Our reaction uses a compound called 3-hydroxypropionic acid and ammonia as feedstock. Our reaction occurs over 3 steps, where this 3-hydroxypropionic acid, 3HP, is dehydrated into ethylacrylate. Ethylacrylate, along with ammonia, undergo aminolysis to produce acrylamide and ethanol. And these intermediaries then undergo dehydration to produce acrylonitrile and water. And today, this pathway, this nitrolation reaction, has been scaled up to a technology readiness of 7 out of 9, which means that it's at its earliest stage for deployability. And here's a little more details about our process. So we intend to source our CO2 from the air or industrial point sources, reduce it to carbon monoxide, and along with a bio-based input over a catalyst, we convert these raw materials to our intermediary 3-HPA. 3-HPA is then processed through our nitrolation, our patented nitrolation system to synthesize acrylonitrile. And at full commercial scale, which is defined for us as 50 kilotons per year, we're designing our units to be resource efficient. We can recycle 95% of the ammonia and 99% of the ethanol back into our nitrolation process. We also use a fully renewable mix of grid energy, all while producing more of the product with yields of 98%. And without any additional purification, our product is 97% pure. The only impurities are water and ethanol. And for our customers, this is really important because we're selling a commodity and our product needs to be molecularly identical. And to really drive this point home, and just how game-changing our technology will be, here's just an overwhelming list of all the benefits of nitrolation stacked against the conventional process. There are so many benefits to our technology, but really what's most important to us, and when we don't show this entire full list, is it's lower CapEx, it's lower costs, it's lower carbon intensity, the higher yields, and the fact that we're able to use CO2. And I think this data really shows why we selected nitrolation. Nitrolation will enable us to clean up the acrylonitrile industry, which we can talk more about later, and pump captured CO2 back into its supply chain, all while making acrylonitrile cheaper. And for us, with cheaper acrylonitrile, which is how we enable the growth of carbon fiber. But once the acrylonitrile is polymerized into the PAN precursor, there's still more to its journey. So you have the PAN precursor, ideally derived from our process, so using captured CO2. The next thing you need to do is thermally convert it into the PAN precursor into carbon fiber. So this process varies by manufacturers and is mostly trade secrets. So I'm going to generalize this here, but it generally follows kind of 3 steps. You have a stabilization step, a low temperature carbonization step. The precursor gets heated at rising temperatures until the fiber is formed. From a scientific perspective, there are a bunch of reactions happening here, and it's all kind of still unknown. But what we can observe from the techno-economic perspective is that this is the most energy-intensive step of the process. There's also some CO2 loss and other gaseous emissions. And after the fiber is spun, it's then time to mold the fiber. Again, this step is specific to individual manufacturers. However, the general flow follows the fiber is impregnated with a resin. This can also happen before. It's arranged into a mold, and then it's cured to preserve its shape. And then, as I mentioned, end of life. At Mars, end of life is just so critical, and it was one of the foundational questions that we had when we began our discovery. It's important to us because from the carbon dioxide removal principles of permanency, and just where the material physically ends up has impact. So carbon fiber production is notoriously wasteful. It's estimated that 30% of carbon fiber is scrapped. When we conducted our discovery on nitrolation, we really wanted to learn what was being done to improve carbon fiber end of life. We learned there's a growing manufacturing community of nonprofits and startups really working to convert these scraps and use fibers into sporting goods and building materials. And all of this is important because the ubiquity of cheaper carbon neutral carbon fiber not only means an incredibly useful carbon sink, but also exciting uses for carbon fiber. And the examples I'm going to share have all been piloted in the real world. So for example, carbon fiber reinforced conductors. AEP, which is an electric utility, they piloted 250 miles of carbon fiber reinforced conductor. What they found was line loss reduced by 30%, and they were able to increase capacity. I live in California, where wildfires are often caused by utility transmission lines, and being able to transition to a better conductor could prevent some of those. Moving down the kind of chain here, carbon fiber for vehicles will enable lightweighting. And not just for internal combustion engines, which could improve fuel efficiency, but as we talk about transitioning to electric vehicles, that translates to a smaller battery at the same range. So using less materials for that battery production. And then finally, really replacing corrosive steel with carbon fiber as a concrete amendment can extend the life of buildings and limit cracking of concrete. As we are working to store CO2 into concrete structures, making sure that we're able to store that permanently with a better composite amendment is really important. And as you can tell, we're kind of nerd out about carbon fiber here, but we do have a long way to go in our commercialization. Just wanting to close out our conversation with kind of what's next for us. So today we are hiring a process engineer to help build our first unit. We're also looking for pre-seed investors and grant partners for our scale up. And then finally, we are looking to connect with potential supply chain partners and customers. You have my email and Christian is also in the chat, so feel free to reach out. And with that, I just want to thank you again for listening and learning more about Mars Materials. We are incredibly excited to share our technology with the OpenAir community, and we're really fortunate for this opportunity. We believe that carbon capture and utilization is a key industry that will help to increase the demand for direct air capture. And from our perspective, creating a high growth raw material from CO2 is a right early accelerant. So I'm really excited for questions. And with that, I don't know if I turn it back over or whatever the next steps are.
Yes, that was fantastic. Thank you so much. We have a bunch of audience questions. We have a couple of prepared questions that we'll start with, and then Megha is going to organize and pose the audience questions that have come in. But thank you again. That was a really informative and great presentation. Can you talk a little bit about there are a lot, I think a lot of the audience is really familiar with Carbon 180. Can you talk a little bit more about your time there? You were in a cohort with some other really great founders of exciting companies. Can you just talk about what that was, what that year was like, and where you started and where you ended up in terms of your journey with Mars? Because you had the idea previously, but I guess, can you talk about that?
I had the idea of identifying greenhouse gases. At the time it was methane, and seeing if we could just do something with it before it emitted into the atmosphere. So Carbon 180 really encouraged me to think bigger, think about the air that's the gases that are already in the atmosphere and figure out if there's opportunities to leverage those. So the opportunity just kind of expanded my horizon for what was possible. As a non-technical founder, I was kind of a crazy man at the start, just knocking on people's doors, wanting to learn like what could be done, why things weren't being done, and just figuring out, hey, is there something I can do to use my entrepreneurial skills? I've been a founder 3 times now, to just move some of these technologies to market. So Carbon 180 gave me a platform. They gave me the introductions to the right stakeholders to help me really quickly iterate and determine if the idea or the concept that I was considering made sense on a not just the environmental perspective, but also on a solid business foundation. I will say that our program started a week before the pandemic struck, so we all got to meet in person once. And I'm just now starting to meet the fellows again in person as we're kind of moving away from the peak of the pandemic. But the program itself also gave me a community of just like really talented and passionate people to connect with on a daily basis, to run my sometimes crazy ideas by, also just to vent and really help me understand that I'm not in this alone. This is such a long journey. We're all looking to transition industries that have been really entrenched for the last 150 years. So, the program gave me insights that this is something that we can all do together, and that was really helpful.
I would assume that too, like there's a lot of really great cross-pollination between the different projects because they were very different, but all working for the same goal. Besides Mars, is there a particular emergent CDR pathway or technology that you're kind of personally excited about?
Yeah, so I shared a little bit about our thesis, but I also, but I didn't share like what's in the name. So Mars Materials really comes from the idea. It was in some ways a joke. I think all these billionaires are talking about going to Mars and building colonies, but we have a planet right here that needs healing that we need to, unscrew up. So when I think about Mars, that atmosphere is about 95% CO2. So it becomes a guiding form for us. What would you do with all that resource on a planet that needs, to kind of build everything from scratch? So that becomes a kind of a true north. And when I think about that, the materials that you would need are kind of sugars to create other chemicals. So I really like the idea of CO2 to sugars. We looked at a couple of the processes. They weren't at the level of tech readiness that benefits me as an entrepreneur. I am a non-technical founder again, so my strengths are in kind of building the business relationships and being able to get something to market. So if the technology is still in that kind of discovery phase, I just can't be useful.
Got it. This is going to overlap a little bit with some of the life cycle analysis questions that are in the chat, but just can we recap? So we're focused with this series and kind of with our policy proposal on permanent 100-year plus carbon dioxide removal pathways. And one of the sequestration opportunities for CO2 that's captured is the built environment. So can we maybe, and this is recapping some of the things that you said, but so per ton of carbon fiber, can you talk a little bit more about what the efficiency of the process is in terms of emissions? What is the net removal per ton of material? And maybe gross and net. So how much CO2, just recap those numbers, or per kilogram, whatever the right unit is.
Yeah, so I can really talk about nitrolation and where we fit into the supply chain. So for our technology on a unit perspective, we are able to use 0.83 kilograms of CO2 per kilogram of acrylonitrile produced. When it comes to our emissions intensity, that it's primarily from energy use, and that is about 2.3 kilograms per kilogram of acrylonitrile produced. So you can do the net there. We like to compare this to the existing Ohio process, which is fully extractive. So when you do the comparison by comparison, you see the advantages of our technologies. When it comes down to then further processing our raw material into pan and down the carbon fiber supply chain, what they have are scale, economies of scale, but they also have a lot of trade secrets that they use. So getting some of the insights into their full life cycle isn't something that we have complete visibility on today, but we're working to get.
Back to that 2.3 number, the emissions intensity just for the production of the raw material. And you said that was from energy. Does that go away if you're powered by renewable energy, or is it a process emission that does not go away?
Yeah, that's a great question. It's primarily from our distillation train, and we anticipate it going away, but we are looking to, so we've done something really hard. We were able to execute on a license or an option to license the technology from a national lab, and one that doesn't have as many startup partners as usual. So we've been working off of NREL's LCA, and we're working to develop our own internal one that we can use. So we'll have some more insight into specifically how low we can go on carbon intensity after we finish that project.
Got it. And also for the process to result in ultimately removals, you would need to work with CO2 from direct air capture as opposed to any sort of point source carbon capture. Have you thought at all about how that supply chain would work as you scale? Would the DAC be on site with your production facility? Have you kind of talked with, obviously you were in a cohort with Heirloom at Carbon 180. Have you talked with any early stage or late stage DAC companies about how you might collaborate with them? Yeah,
so we've conducted, I wouldn't say as extensive discovery in our supply chain as we have with our manufacturers, with potential manufacturing customers. But we have built a pretty sizable list of supply chain partners, including direct air capture companies and producers of point source emissions. Our scale-up process from a kind of supply chain perspective is tied to our technology scale-up process, but also tied to our commercialization strategy to get to market. So at the start, we are looking to we'll leverage emissions, captured carbon monoxide from steel refineries if possible. That will allow us to cheaply create our intermediary, the 3HP that we need. As we are able to scale up and have more buying power, then we have a plan to transition to captured CO2 from point sources. And as the cost of DAC declines and our ability to reach scale has kind of already been there, we see opportunity to partner with direct air capture producers. Today, it's just very expensive. We're selling a commodity, and the only thing that we hear from our customers or prospective customers is that cost is important.
Yeah, that makes a lot of sense. But so there is a future, and there's a question that audience question that we'll get to later about what your kind of physical plant might look like in the future. But is there an opportunity potentially to co-locate direct air capture with your production facility to kind of eliminate those transportation costs so you have on-site capture?
That's a great question. So we're looking at two pathways for our facilities. One where we own and operate them, and this is how we're getting to market. And there we would look to co-locate our feedstock plant, which would include the direct air capture module as well. And then long-term, we would seek to place our units on site so the nitrilation units on site for like a carbon fiber manufacturer. That's important for that particular segment because they want access to acrylonitrile more regularly. So we would have to figure out based off of our LCA how where we locate our feedstock plants in addition to kind of that scale out opportunity with our units.
And insofar as you can talk about it, kind of your early path to commercialization, do you have a preference or preferential beachhead markets that you're looking at that you think are going to be the easiest to kind of initially go after?
Yeah, so we have exclusivity in a market called acrylamide. And what we've learned is, so our product after synthesizing is 97% pure. Expanding into carbon fiber long-term makes sense, but the requirements for a carbon fiber acrylonitrile product are about 99.6%. So that requires additional modeling on our end to really understand how that impacts our techno-economics and our life cycle. But to get to market today, we have a pure product that allows us to enter into the acrylamide market. And acrylamide is a $4 billion market. It's a polymer primarily used for the treatment of wastewater chemicals. Nearly every wastewater treatment facility on the planet has secondary treatment. And this is where you separate the wastewater from solids. And using a flocculant primarily created through acrylamide called PAM, you're able to purify the wastewater or purify the water and separate it from the sludge. So what we've learned from that, our discovery, speaking with all the manufacturers in that market, is that the costs are skyrocketing, primarily because of the rising demand of acrylamide, and also because of regulatory pressures to improve the end of life for sludge management. So there's opportunity there for us to enter into this market, reduce the cost, and help improve that overall life cycle.
Got it. You mentioned regulation there. Is there policy innovation are there specific policy innovations that would help you accelerate your go-to-market that you're thinking of or that you've kind of run into?
Yeah, great question. And that's something that we're kind of learning on a daily basis. What we have learned is if we want to enter into the municipal wastewater market, we need to begin looking at changing the spec sheet for PAM purchases. So making it so that we're able to, that municipalities start to look for and source from kind of renewably sourced PAM. So our first step is to partner with the American Wastewater Association in their local chapters with different states and see if that's something that we're able to do.
Got it. That's great. So one last question before we flip to the audience questions. You are, and it's about the New York State, kind of our local carbon tech ecosystem here in New York. You are part of two programs, I believe, Venture for Climate Tech and the Carbon to Value Initiative. Could you talk a little bit about your experience in those programs and how they've been helpful to you, and maybe just sort of general impressions of the carbon tech sector and ecosystem in New York?
Yeah, those programs kept us busy, but they also got us to where we are today. So we're very grateful for NYSERDA, for the team at Carbon to Value, for the team at Venture for Climate Tech for really assisting us. We came in with very specific goals for each of those programs, and our outcomes, I think we met many of them. So on the Venture for Climate Tech side, we really wanted to get our internal operations organized and be able to create the roadmaps that we needed so that we're able to launch our pre-seed round and really start executing on our tech development goals. When it came to Carbon to Value, as an outsider to this industry, we had no contacts in the carbon fiber market. Oh, we had a few, but we also didn't have a beachhead. So Carbon to Value gave us a list of, I think, about 10 large global corporations that were able to quickly, let us know if our idea made sense, and if it did, where we could land. So both of those programs really helped to shape where we are today, and we're so grateful for that. In addition to that, the NYSERDA support wrapped around these programs, from just from the grant money to the entrepreneur in residences that they provide to bridge our knowledge gaps, was really just incredible and insightful, and still continues to be very helpful. And your last question was around the New York ecosystem.
Yeah.
Right.
Yeah.
And we see an opportunity to turn New York into a carbon sink. That isn't necessarily from a geological sequestration basis, but from the large number of buildings that need to come online as New York City grows and other cities around the state grows. So, we've envisioned carbon fiber, once we're able to address a lot of its, life cycle issues, being that new material that enables that and also helps to facilitate that along with the other kind of transitions that are happening along with other building materials.
That's great. Yeah, we're at OpenAir, we're very excited about that as well. I mean, concrete is, I think being able to sequester CO2 in concrete is closer to market or, ready to go now. And the idea that there would be other alternatives in the built environment, I think are very powerful. So that's why it was very exciting for us to have you with us today. And one, Chris just put in the chat, you do the C2V, I mean, both programs you're with some really interesting and exciting companies. The C2V has a showcase on Thursday, and Chris put a link to the chat that I encourage everyone to attend. I guess all 10 of the companies will be presenting, and I think it'll be really a great program. So I encourage everyone to join that as well. Thank you for answering those questions. And I believe Megha is going to pop on now and handle some of the audience questions.
All right.
Hey, yes, we have a bunch of questions. I'm going to start ones later on. So the first question, which I'm sure you get a lot, is can you talk a little bit about the typical lifespan of carbon fiber and how that compares to other carbon removal solutions out there?
Yeah, so I mean, carbon fiber, once it's in its, well, the fibers once in their carbonized form last for a very long time. They're resistant to environmental issues and factors. And what that means, though, is you have these fibers that can last near forever. So what is done at their end of life, and that's a big issue for the industry today. And what we're seeing are a bunch of companies, primarily startups and nonprofits, working to improve that end of life. So as I mentioned, 30% of carbon fiber is scrapped. So there are nonprofits working to turn that scrap into municipal benches, for example, and building materials. The carbon fiber that is already in use in airplanes, for example, a lot of that is now coming to its end of life. I don't recall the full life cycle of an airplane, but I think it's about 3 decades or so. And forgive me if I'm wrong here. But as these airplanes are kind of coming offline, we're trying to figure out what to do with recycling them. And there are companies here in the US and overseas in Europe that are focused on kind of pyrolyzing the resin off of carbon fibers and then using these new fibers for cement amendments, for example, to help improve concrete things.
Okay, yeah, we do have actually a question on the concrete amendments. So the question is, are you looking at using carbon fiber as a reinforcing fiber for concrete, and about how much, do you know how much can be included percentage-wise in concrete?
Ideally, yes. So we would love to use it as an amendment, replacing it with rebar, for example. There's a building, I believe it's called Carbotech, that comes online in Europe, and it's fully carbon fiber. It's fully derived from carbon fiber, and it's a pretty, I think, incredible pilot opportunity here. The material use for carbon fiber versus steel, I've seen anywhere from 40% to 70% less material. So you just need less of it. The exact amount when it comes to different building materials and concrete amendments, I can't comment on because it's not my area of expertise. But I think it's anywhere between 40 to 70%.
Okay, cool. And I mean, outside of concrete, what are some of the other initial target customers that you have in mind, or like who are you thinking about sort of first versus medium versus long-term types of customers that you'd be working with?
Yeah, so this kind of goes back to our go-to-market. So we are initially targeting the acrylamide and polyacrylamide market called PAM for wastewater treatment. That's where we're able to, I think that's where we found fit with the initial stage and scale of our technology. As we kind of land the acrylamide market, we intend to expand into carbon fiber. And there, it's really driven by price points and the company's end of life management and where the material actually ends up. So, until I think carbon fiber is fully carbon neutral or carbon negative, we really want to be strategic about where it's used. And for us, that means partnering with organizations that are looking to use it for decarbonization and across other industries. So I think that kind of goes back to the use cases that we considered, which is carbon fiber for reinforced conductors, carbon fiber for vehicles, carbon fiber for buildings. And all that will be really contingent upon the price points and what's required there.
Yeah, it makes a lot of sense. A couple of people asked about essentially non-technical challenges that you guys face. So what are your biggest non-technical hurdles to getting adoption? And sort of on the same note, what's your biggest short-term business challenge? And how are there any policy changes that could happen that would make a difference and lessen the challenge?
Yeah, so just kind of talk more about the policy change first, because it goes back to, I think, the last question on our intro market. We're looking to make it so that the PAM flocculant can be sourced, or there's incentive for wastewater treatment municipalities focused on wastewater treatment, to source PAM from bio-derived sources, renewable sources. So that's one change that we're looking to have done, and we're looking to get the certifications that we need to do that. But to get there, there's a whole process of kind of materials testing with our potential customers that's required. So I would say that's a new thing for me. I've built software businesses and have worked in clean tech, but I've not worked in materials. So those kind of staged approaches towards material testing has definitely been a setback, but it's also a good way for us to build early rapport with potential customers. In terms of other kind of areas for business challenges, I wouldn't say we have a lot of business challenges per se, but I will say that everything takes just significantly longer in terms of building business relationships and rapport with potential stakeholders, and really figuring out, I think this is where Carbon and Value and our mentors with Carbon and Value have been so helpful, really figuring out what each stakeholder's motivation is so that we can align that with what we're trying to do so that we can kind of unblock ourselves.
Right, okay. Another question we had was about being a certified B Corp. So have you seen that as a big help in raising investor money, or is it too early to tell? How's that kind of worked with your fundraising?
Yeah, I mean, I would hope that the climate investors and folks who are interested in working with us don't mind that we are a certified B Corp. Our B Corp status was really around to create guardrails for our technology and our mission. Our goal is to only commercialize technologies that remove and sequester greenhouse gases and pump them back into the supply chain. So to do that, we wanted to ensure that if we any new technologies that we take on after we're able to kind of achieve scale here really follows that mission. So that that keeps us oriented in that direction.
Right. Okay. We got a couple of questions about kind of where you're thinking about locating. And I think one was, does it make sense to locate your commercial system near renewable energy sources? But another was, are there any other industries that you think about co-locating with? And I know we talked a bit about DAC already. So is that something you guys are thinking about?
Yeah, this is going to be driven by our TEA and by our LCA. And today I don't have a best answer for that. Siting is something that, I think companies spend a lot of time on and can cost, and that's something that we want to be driven by the data for, and also and figure out what makes the most sense for us. So don't have an answer for you today, but the goal would be to make it so that we have the least carbon intensive path, and also a path that is cheapest for our customers.
Right, okay. And then, a more general question, I guess, when do you see the earliest that this technology could really be deployed at scale?
Yeah, so we are working to create our pilot facility. We anticipate being able to begin development on that following a successful fundraise. And we would hope to use that data to convince one customer. The PAM market is pretty small. So about 80% of acrylamide goes towards PAM. And then there are really only two kind of major global distributors of PAM. So we would hope to be able to partner with one of those customers who we've been in talks with to launch our first of a kind demonstration facility, scale that up over year 2.5 to kind of 4, and then use that data to launch our commercial scale unit. So somewhere within kind of 5 to 6 years is what we anticipate. And that's being pretty conservative. We don't like to be uber aggressive on timelines, but we do see opportunities to ratchet that up and move faster if we were to raise more monies and expand our team faster.
Yep. Okay, makes sense. Another question we had was, how have carbon removal credits factored into your business model, if at all?
Yeah, that's a great question. To be perfectly honest, they haven't quite yet. I think they will as we begin to leverage capture CO2 from point sources or from direct air capture. But what we wanted to do was to create a business that could stand on its own without the need or heavy reliance on the carbon markets, and then build the system so that as we get to scale and hopefully the politicians can get their act together and figure out the carbon markets, we can then tap into that, and that can lower the cost of our technology even more. But for right now, we're just using the technology's I think kind of killer stats as the basis for our economic models.
Got it. We had a couple of slightly more technical ones, which I'll get to now. So one of the questions was, can you talk about any functional differences, if there are any, between carbon fiber?
Yeah, and that's a great question, and that's primarily the question that manufacturers have, and that we're going through diligence with them for. So the impurities from the conventional process to produce acrylonitrile and PAN is a longer list than just hydrogen cyanide and acetylonitrile. It's about, I'm going to say, like 15 different impurities. So the production lines, at least for carbon fiber manufacturers at scale, and this is not necessarily looking at the independent shops, they are very optimized around kind of removing these impurities. And they're so although we only have 2 impurities, water and ethanol, those different concentrations can impact their production line. So what we learned is that we just need larger volumes of materials for them to test, and we'll hopefully have that characterization done sooner than later.
Cool. And just a last question. I mean, I know in the OpenAir community, there's a lot of people excited about using carbon-based materials for things like 3D printing. Are there any other kind of cool new applications for this that maybe people haven't thought of that you think might be interesting somewhere in the future?
Yeah, I definitely like the idea of 3D printing. Actually, my first kind of introduction into carbon fiber as a serious kind of competitor to steel was a couple years ago, prior to even looking at Nitrolation. And I met a guy who was looking at creating the carbon fiber filaments for 3D printing. So learned a lot from about that process from him. I think in terms of kind of what carbon fiber can be used for, we really specifically look at carbon fiber as a decarbonization tool. But if you think of, or you look around your place, I would just encourage you to see, like, what steel is in your house, what aluminum's in your house, what some other metals that are in your house and other materials, and just kind of imagine all of that being replaced by carbon fiber, because it's possible. And I think you'll start seeing the world the way we do. And you'll see a lot more promise there. Again, assuming that we're able to really reduce the energy intensity of this supply chain and get the product to a good carbon intensity.
Yeah,
Ideally,
cool. That's a cool way to look at it. Yeah. I think we're going to wrap up now. We're almost at the end of our time. But Aaron, thanks so much. It's been super interesting and informative. And I'll hand over to Toby just to wrap things up for us.
Yes.
Yeah, thank you.
Thanks again. That was really great. And also thank you to the audience for so many amazing questions. That was really, really helpful. I'm going to share my screen here and show what is coming up. And I also just put into the chat links to Mars Materials website, to Aaron's Twitter, and to Mars Materials Twitter. So please follow them. But thank you again, Aaron, for being with us today. And we will see you on Thursday at the C2V program. Coming up next on This Is CDR, on a week from today, we have Project Vesta, which will be very exciting. And then in November, December, we have a kind of a murderer's row of CDR companies there: Running Tide, Charm Industrial, Planetary Hydrogen, which is also part of the C2B initiative, and Noya and Sea Change. So lots of great stuff coming up, and really grateful to Aaron for being with us today, and look forward to seeing you guys next time. Thank you so much.